Welcome to this very short presentation of our technology. Um, Today we are not presenting a product. We are trying to make you see our vision of the future. It could be the difference is because is more a direction in which we are going that eventually solidifies in a product. But the vision is more important. For years, MEI technology has helped our customer in the edging, in the industrial edging. We provided edging machine and allowed our customer to grow in this field. After this short presentation, my colleague can give you a small bag with inside a lens with some refining that show some of the new development we have done in the edging. They are cosmetic refining like engraving and chamfering for aesthetic purpose. It's just an example. Today, the edging is still our major business. But of course, in terms of R&D, we are more concentrated in the surfacing machine. We believe in a visionary mindset. So we believe that MEI as a company has to try to revolutionize the process rather than improving them step by step. So some years ago, we came up with a bold question. How can we improve the surfacing process of the lens? For sure, it was a challenge, has been a challenge for us, because as an edging company, we didn't have the experience to work on the surfacing. And definitely, we wanted to do something transforming the industry. So we asked ourselves, what if we can do the surfacing without the block? For sure, it was a sort of rebellion against the status of the art, because the block has been there for many years, has been considered a very crucial part of the process. And trying to remove it appeared like a silly idea, a naive idea. Okay, it would be nice to have this and this and this, but it's not doable, right? So we believed that it was possible. And we believed that it was possible to create an industrial machine working without the block. And we were the first to try this solution. And moreover, the first to create a really working machine. Because one thing is making a prototype, making a test equipment that proves the concept. Another matter is make a machine that produces the lens, that proves to be sustainable, that has a return on investment that makes sense, and also has a smaller footprint, a smaller impact in the lab. Obviously, for the operators, I don't know how much familiar you are with the generation of the lens you are, but removing the block, it means remove a lot of steps before the generation and after the generation. And everything becomes more simple. So seeing the advantage, easy. Making it real, very difficult. Okay, so everyone agreed that ideally removing the block, the process would be a lot better, no? But to make it real and to transform it in a real machine, very, very difficult. We have to redesign the surfacing process from the very beginning. to achieve this final result. So today we have our core TBA, which is an all-in-one lab that sits in 2 by 2 meter, so total 4 square meter, able to produce a complete freeform lens. This helps a lot the small to medium labs. But we never stop hearing our customers say. So we understood that this was just a starting point for this journey. So we started to think about how to improve the throughput of the system. And this is how the new solution came into the scenario. New solution is the one that you see behind me here. It's alpha plus omega. In this new design, we split the generation and the engraving from the polishing. So now there are 2 different machines connected via our easy line conveyor system, in which we can produce 100 lens per hour. And this setup, in terms of cost, is lower because in this machine we are sharing all the fast devices. Like in example, the laser engraver can support 2 machines like that. So we have just 1 machine to support 2 machining cells. With this strategy, the same machining cells, so same technology, proven concept, different automation, different layout. This allows lower investment, lower cost, and allow to double the throughput because we doubled the machining cell. It creates a more easy to maintain situation because we can access the machine from 2 sides, so the maintenance is easier, and the technology and the return of investment become even more convenient. The setup that you see here basically include also a machine that washes the lens after the surfacing. The lens after the surfacing come out nicely clean from our system, especially because we don't have any glue residual on the lens, which is a typical problem on the alloy technology. Also in the Satislow resin, you may have some residual on the lens. So you need a strong cleaning action. The lens coming out from here is clean. You may have some minor residual of slurry. It's the only thing you need to remove. So this machine, very compact and very efficient, does this job and prepare the lens for the coating. But in the quality, it means the quality that our machine produce is also linked to the timing. I'm explaining a little bit what I mean. The inspection, the quality inspection of the lens that we generate, we felt to be crucial to have an inspection immediately after the generation, because in this way you avoid to produce reject jobs, and you can tackle, in example, some parameter that is drifting. So if you have a tolerance that is going progressively toward the rejection situation, you can interject this situation before it becomes a problem. For this reason, inside our machines, we have a device which is called power matching. The power matching is a mapping system able to compare the theoretical map with the real map and understand, controlling 100% of the lens, if there is something that is going wrong before the problem become a real reject. So this function that comes with without block process, because the lens is completely clean and completely free. You can do a transmission mapping, and through this is possible to do this inspection, which is very, very important. After the generation, we have this cleaning machine, which is basically doing two different functions. One is to complete the cleaning before to enter into the coating. And the second function is to do the cosmetic inspection. Because in the generation cell, we control the map, we control the power, how precise the recipe come out. But we do not control the surface quality, in example. Why? Because the lens is clean, but is not clean enough to do a real cosmetic inspection. So we need to do the wash before, and then we can do the cosmetic inspection in this. So after this machine, the lens is ready to go to the deep coating, and then to the speed coating, and then to the vacuum chamber to finish the coating itself. This machine has a double capability. We can set the machine up to clean the lens after the edging. This is not the case, but over there is an edger with the cleaning machine after that. The cleaning process after the generation and compare it to the cleaning process after the edging is completely different. The kind of dirt that you have, the kind of moisture that you have on the lens is different. But the base machine is the same. We have two different configurations, and we can set the machine in a different way. But both solutions can have the cosmetic inspection inside, which is very important once you need to avoid other people to check the lens and inspect the quality and so on. So this is our vision fully realized. A very an automatized process, tightly controlled, sustainable, and very small footprint at the end. Thank you so much. I hope you enjoy your stay and you enjoy the video show. And any question you have, I'm here. Thank you. Thank you so much.